going to change our subtraction problems though into addition problems. Because typically here's what happens when students think, you know what, I got this. I can subtract without changing to add the opposite. And it doesn't necessarily always go well. Even for those students who are just convinced they know what they're doing.
I know.
So there's, you know, I mean, I've been teaching long enough and doing this long enough, I know that it's about 1 in maybe 50 students who can really pull it off and pull it off all the time. Okay? So Sage says that's him. Okay, so the rest of you, I guess, you know. Also, no, John, you want to claim it's you. Okay. So what we're going to do is we're going to rewrite our subtraction problems as an addition problem. When you rewrite a subtraction problem as an addition problem, you add the what? Opposite. So we're going to change them to add the opposite. Now, we're going to do that sometimes a couple of different times. First, we may change the subtraction to add the opposite in the polynomials themselves. And then we will go about changing the subtraction of the polynomials to add the opposite. Okay? So, why are you not? You know what you're going to do. Okay, so number 1, we have the polynomial x squared plus x, and from that we're subtracting 3x squared. So since we're subtracting a monomial, there's really nothing else going on in that when there's only the one term, and the first polynomial has just addition. So we're going to ditch those parentheses. Oh, no, we're not. We're going to leave them there for a second. I'm sorry. We're going to leave those there. That polynomial is going to stay as it is. And then we're going to change this subtraction right here into an addition problem. And when we change the subtraction between the polynomials, the polynomial that is being subtracted, every one of its terms, every one of its monomial terms has to change to its opposite. So there's only one term to change to its opposite, so we're going to change the 3x squared to negative 3x squared. We're really not going to ditch those parentheses yet. So there was no subtraction to change within the polynomials themselves. So then we went straight to changing the subtraction between the polynomials. When we change that, we are changing it to addition. Nothing happens to the one that we started with. We only change the polynomial that's being subtracted. Every term is changed to its opposite. Okay? Now we can ditch the parentheses and rearrange our terms. I just rearranged them all in that same step. Maybe shouldn't have. That might be a little confusing. Let's take that back, okay? Some of you looked at me a little funny, so I'm thinking that. No, let's just ditch the parentheses like we would have done yesterday when we didn't do everything all in one step. Now we're just going to follow the same things we did yesterday, which is rearrange the terms so like terms are grouped beside each other. And we want our answers to end up in standard form when they can. So we have x squared plus negative 3x squared. What does that combine to be? That's a negative 2x squared. And we don't have another term to add that x to. Is this as good as our answer can get? No. Doesn't have any more like terms? No. Can't be cleaned up? No. Is in standard form? Yes. Okay, so we're going to call that our answer. The difference of those two polynomials, remember subtraction is difference. The difference of those two polynomials is negative 2x squared plus x. Okay, let's go to number 2. First thing we're going to do, we're not going to change that subtraction in between right now. We're going to, when you look at it, you can see that the first polynomial has subtraction in it. So let's just change the subtraction in that to add the opposite. So instead of subtract 3y, we will have add a negative 3y. And we're not going to mess with that subtraction between the polynomials yet. We're just going to leave it alone. We don't have any subtraction to change in the other polynomial, so we'll just rewrite it. Let's bring it down. Now, in the next step, we will take care of the subtraction between the polynomials. So again, we're still not ditching our parentheses yet. We have 9y squared plus negative 3y. That's staying as it is. We'll change our subtraction to addition. And now, when we do change that to addition, we have to have our every piece, every part of that polynomial has to change to its opposite. So it's going to be a negative y squared, and it's going to be a negative 7. The opposite of y squared, negative y squared. Opposite of 7, negative 7. And now we're ready. We have it as an addition problem we can do as we did yesterday, which was drop the parentheses. So we have our 9y squared plus negative 3y plus negative y squared plus negative 7. Let's turn it into a addition problem of all monomials. Okay, now we can rearrange and have our like terms. Which term should we start with? So it ends up in standard form.
Y squared.
The y squareds. 9y squared plus that negative y squared. What term should we have come next in our rearrangement? The negative 3y. Okay, we don't have any other y's. So the only thing we have left is that constant negative 7. Okay, so what does this become? What is it? After we add all these, do we do our addition and we can only combine like terms? What is our polynomial answer? Riley, what do you get?
8y squared minus 3y minus
8y squared minus 3y minus 7. So we combine the like terms and cleaned it up all in the same step. 8y squared, take away the 3y, take away 7. You always look at your final answer though and make sure. First of all, are there any like terms in that polynomial answer? Are there any like terms in that polynomial answer? No. Is it in standard form? Okay. And why can we talk about it being in standard form? Because it's what? Only got one variable. We talk about it being in standard form when there's only one variable involved in it. Okay. Any questions so far? Okay, there's all kinds of subtraction going on in that next one. All kinds of it. So what's our first move going to be?
You add the opposite for the first one.
Add the opposite in the first polynomial. Okay, so, so we can change this one to 7m to the 4th plus negative 2m squared
And then you add the opposite
for the other polynomials, right? We're going to leave this subtraction right now. Don't try to do this subtraction along with the subtractions inside the polynomials at the same time. That's typically where it starts to take a wrong detour for you guys. So this is going to become 5m to the 4th. There's a subtraction there, so we'll make it plus a negative 5m squared. There's a subtraction there, so we'll make it plus a negative 8. Aaron, what did we just do?
We went through and we put them all together in order.
No, we did not.
No.
Must have been where you were at in your dream, though.
Yeah.
Yeah, okay. So we've changed the subtraction within the polynomials themselves. Now we're going to change the subtraction of that. We're going to add that second polynomial instead of subtract it. We're going to add the opposite. So the first polynomial stays as it is. 7m to the 4th plus negative 2m squared. That stays as it is. It's what we're subtracting from. We don't mess with it. We change the subtraction in between the polynomials to add. But now when we change that to add, everything in that other polynomial has to change to its opposite. So what's it going to be? What's our other polynomial going to be? Negative 5m to the 4th plus
5m to the 2nd.
Opposite of negative 5m squared is 5m squared, plus the opposite of negative 8 is 8. It is huge that we know how to add and subtract polynomials for being able to be successful in multiplying them. So we have to make sure that we're really especially treating subtraction properly. Now we can ditch the parentheses and say, you know what, I have a whole bunch of monomial terms here. In fact, there's 2 in the first one, 3 in the second one, so I should now have 5 monomial terms that can be added together if there are any like terms. So go ahead, rearrange, and get your answer. Clean it up. Have it in standard form. If you had 5 terms after you drop the parentheses, you should have 5 terms after you rearrange it.
It's incorrect.
Is it?
Yes, it's
3
incorrect.
Oh, is it m squared and an m? Thank you. And that would cost you a point on a quiz. Cost me a point on a quiz because I just forgot. I left the squared off of the m. So it's always worth double checking your answer. And you got it for me. Thank you. Do we agree though on the rest of it? You know, other than my mistake. Okay. Anybody have questions? Okay, you're so confident. Okie doke. Let's go to the back side then and do some word problem ones. Okay, read through that first one, number 4. I'm thinking that since we're in a lesson where we're adding and subtracting, we're probably going to have to do some of that. Anybody have a suggestion what we need to do in this one? Because it says write a polynomial for the total volume of the 2 boxes. The idea is what we could do. 2 boxes in a storage unit, they give us the volume of the first box, they give us the volume of the second box. They tell us to write a polynomial for the total volume. John?
Well, you would just add them.
Add them, okay, so add the
No,
volumes. So we have this volume to add to this volume. Okay, let's set it up. Parentheses, this polynomial needs to be added to the other polynomial because it is given as volume of one, volume of the other. Add those 2 volumes together. And we need to stay in the habit of when it's a polynomial, start it out in parentheses to show that they were a team together, all those terms. So we have our first volume added to our second volume. We can, because it's addition, we can just ditch the parentheses and change any subtraction to add the opposite along the way. And when it's addition already, we don't need to worry about those parentheses. It's like they're really immaterial. Even though I said to write them there, we need to stay in that habit. Okay, go ahead and finish that one up. Find the volume of those 2 boxes. The total volume of those 2 boxes, I mean. So when it says write a polynomial, that's what we get. We get a polynomial, don't we? What kind of a polynomial do we get? No? It's a cubic binomial, isn't it? Now, that cubic binomial is representing what?
Total volume.
Total volume. So we need to give it a label. Yeah. And when we label this, because there's more than one term, it's not just a monomial, because there's more than one term, it's a more than one term polynomial. When we're going to label it, we have to put those parentheses around it to show that that whole expression, that whole polynomial represents whatever we're going to label it. What's our label going to be? Well, we can do. Did we know what was measured in? Did they ever say cubic units? They didn't say what kind of units they were, but they said that they were units anyway. So we'll call it cubic units. Whatever those units were of measure. Why is volume cubic units? Or if we do it with feet, we would say cubic feet.
It's feet times itself 3 times.
Yeah, because when you're finding volume, it's three-dimensional. You multiply something times something times something. You have three things that were measured in. So if they were measured in feet, it's feet times feet times feet. It becomes cubic feet. Volume will always be cubic units, always, because it's three-dimensional. Volume is how much space there is inside. Okay, let's take a look at number 5 then. So the recreation field at a middle school. I'm going to put a line going kind of separate, and you might want to do the same thing in your notes so that you can keep those problems separate of each other. We have the recreation field at a middle school that's shaped like a rectangle. It has a length of 15x yards and a width of, I'm thinking it might be a good idea to draw this rectangular recreation field. It has a length of 15x yards and a width of 10x minus 3. Write a polynomial for the perimeter of the field. Then calculate. Well, let's just worry about getting our polynomial perimeter first. How do we find perimeter of that field? Add all the sides. Okay, so what would that look like?
30x plus 10x.
Let's not shortcut it though, okay? I know that's probably what's going to happen. So all the sides.
You could add the equations down.
You mean the expressions, the polynomials?
Yeah. And but you have to multiply each of them by 2.
Yeah. So you could do that. You could say I got 2 sides that are 15x. So you could say 2 times 15x, right? Or you could just say 15x plus 15x. And then you have 2 widths in a rectangle. So 2 lengths, 2 widths. It has to be the distance around. So we have 10x minus 3. Because that's not a monomial, we're going to put it in parentheses. Or we could say, put a 2 in front of that 10x minus 3 and do distributive property, do multiplication. Instead of having to add it twice, we could do that. You could shortcut it that way. Okay, now we're going to say, you know what? We have here 15x plus 15x, it's all addition, plus 10x plus negative 3 plus 10x plus negative 3. We can just ditch all those parentheses and then change my subtraction to add the opposite in the same step. Okay, how many x's do we have all together? 15 plus 15? 30 plus another 10? Plus another 10? 50. How many constants do we have? 2. So we have negative 3 plus negative 3. Are we multiplying or adding? Aren't we adding? Plus, I forgot to do the rearrange step, didn't I? Negative 3 plus negative 3. Negative 6. Clean that up. 50x subtract 6, but we know what it's representing. It's representing perimeter. How do we label perimeter? Riley? Yard squared?
That's wrong. Area square. Just yards.
Just yards?
Yeah, just
Because what? Are we doing any multiplying here? Not really, even though we might shortcut and say there's 2 lengths and 2 widths, we're still adding yards to yards to yards to yards. When you're adding, they stay yards, don't they? So these, we put this in parentheses and we say this is our, this right here is our perimeter polynomial answer. So write a polynomial for the perimeter of the field, we just did that. Now we have the really easy part, then calculate the perimeter of x equals 2. So let's write down here, when x equals 2. So what are we going to do? Plug in 2 for x. 50 times 2, take away 6. 50 times 2 is 100. 100 take away 6 is 94.
On page 11 in the What Is It box, there's a picture. Please submit a creative answer as to what you believe this contraption is by noon today. The Bridges staff will declare a winner who will be given a prize. The staff wants a lot of choices, so get them in.
This 94 should be labeled how? Look, we can't go there. This 94 needs to be labeled how?
Yards.
Yards. Some of you cut points off on the last quiz for crazy reasons, like not labeling when we know what the answer represents. 94 yards when x equals 2. Okay. One more, because you're going to be doing some stuff like this in your actual homework too, and you got to make sure you know how to set them up and so that you're going to be able to arrive at a good answer. So we have these 2 cabins that are on opposite sides of the river. And it says they are 12x squared minus 7x plus 5 feet apart. So let's do this. I think we could say, you know what, these guys right here, they are 12x squared minus 7x plus 5. The distance between those 2 cabins is that. And notice we put it in parentheses because we put that label on it, okay? Brendan, what's next? What do we want to talk about next then? After we know that they're that far apart, what else did they tell us?
Now, one of the cabins is 9x plus 1 feet from the river.
Okay, so we could say this one right here is 9, I'm going to use an arrow there. It is 9x plus 1 feet. That's its distance from the river. Okay, what else do we know, Aaron?
We know the minutes. I don't know.
Noah, what else do we know?
Isn't it, the second cabin is 3x squared plus 4 from the river?
Okay, so this other cabin is 3x squared plus 4 feet away from the river, okay? They're asking us to write a polynomial that represents the width of the river, the only thing they didn't give us, where it passes between the 2 cabins. Then calculate. Well, let's not worry about the then yet. We have to find the width of the river. So what would be a good place to start? John?
Well, I think we should start with have the total length from cabin out front,
Okay,
put in parentheses.
okay. So you're saying we would take the 12x squared, you said parentheses, right? Okay, put that out front, you said, okay. And then what?
And then you would have to subtract, let's put a parenthesis, and then another parenthesis. 9x plus 1. Yep, finish the parenthesis. And you add the second length.
So this one?
Yep. And then double parenthesis.
So what's happening here, John?
Well, you are adding the 2 lengths first.
Okay, so we're adding those 2 lengths, the distance, the land distance, basically this is. Let's write that maybe above it. This is the land distance. Out of that total distance, that's the part that's on land, isn't it? And then what's the first one representing?
Total.
That's our total distance, so let's claim that. And then let's see if that makes sense, that we would take the total distance and we would subtract the total land distance, because that's what he's doing there. He's adding the two distances from each cabin to the river. Add those together, that gives you the total land distance. If you take the land distance away from the total distance, should it give you the water distance or the river width? Okay, so let's do it then. So we have 12x squared. That will change that to add the opposite. And we're not going to mess with our subtraction here yet. How about we just do, notice there's no subtraction in that addition of two polynomials there, is there? So can we just ditch that inside set of parentheses John put together? So we could ditch those and say we have 9x plus 1 plus 3x squared plus 4. So we have a polynomial added to another polynomial. We're ditching their parentheses. The other parentheses are still there though, because we have to say that whole thing has to be subtracted from the total distance. Okay, so now let's leave this polynomial 12x squared plus negative 7x plus 5. And we're going to change this subtraction now to what? Addition, and what has to happen inside those parentheses? Every monomial term has changed to its opposite, doesn't it? So 9x is going to become negative 9x. Plus 1 is going to become negative 1. Plus 3x squared is going to become negative 3x squared. Plus positive 4 is going to become negative 4. To get that subtraction to change to addition, every piece had to change to its opposite. Okay, now we can ditch our parentheses. We have 12x squared plus negative 7x plus 5 plus negative 9x plus negative 1 plus negative 3x squared plus negative 4. We got a whole lot of monomial terms. Okay, do that. Find the sum of all of those monomial terms. What is our polynomial river width? I always count how many monomials I have. I rearrange them, I count and make sure I still have that many, because I don't want to leave any of them out. I get 9x squared take away 16x. Know what happens to you?
Yep.
The constants end up becoming 0 when you add them together. The x terms become a negative 16x. The x squared terms become 9x squared. And do we know what this is measured in? What is it measured in? Feet. So we're going to put this in parentheses and say feet behind it. This is the, this also, river's width. It's a polynomial expression representing the river's width. So in other words, if we added that to both of those land distances, it better take us back to the total distance that they gave us in the beginning of this. But I think they asked us to do one more thing. They said, then calculate the width if x equals 3. So that's going to be easy. We're going to put in 3 where we have x's and follow order of operations properly. Do we take 9 times 3 first and then square? we're gonna do 3 squared,
Three squared.
and then multiply by 9. That's good, because I think that'll be easier to do in my head. 3 squared is 9. Anybody know what 16 times 3 is?
46.
48. 9 times 9 is? 81.
33.
81 take away 48 is 33. And that's 33 feet. So let's put over here, when x equals 3, that's what we were finding. When x equals 3, the width of that river is 33 feet. Brendan,
We're missing one thing.
what would that be?
We had a 5 up in the original part of it, but we accidentally took that out when we subtracted by the 4. So we're supposed to have a +1 in there.
Well, there's also though right here, Brendan, see that -1 right there? And when that -1 combines with that -4, it becomes a -5, and that -5 and that 5 are opposites, so they combine to become 0, don't they? So you missed the -4. It's very easy to leave out one of these. Take it out, Teresa.